Hey there guys, this is Mrs. Bowers here. So I am adding a new video to my YouTube channel for some fraction support, okay? So today what I'm going to be showing you and reminding you of is how to name equivalent fractions, and then we'll work on adding those fractions as well. So we'll start off simple by adding just fractions, and then the further we go along, we are going to kind of do like a progression of easy to more difficult. So we'll start with some basic fractions, and then we'll move into some mixed numbers. This is all the work that we've been doing the past week and a half, kind of all compiled into one video. All right, so let's start off with the fractions 2/5 plus 3/8. So we can't begin right away, just jump right into adding, because the units or the denominators are not alike. They are not like units. So I have to make them like units before I can add. Now I taught my 5th graders 2 different ways to do this. You can either draw a picture or use your knowledge of multiplicative expressions to do this. So let me show you what I mean. So first, let's draw a picture. So I'll show 2/5. Please forgive me, I am not Pablo Picasso. All right, so here is 1/5. Here is 2/5. Beautiful. Next, I'll draw a model to represent 3/8. Oopsies. Let's see, need my pen back. There we go. Now I'll do 3/8. There we go. Beautiful. All right, I'm going to shade in 1/8, 2/8, and 3/8. All right, so next what I'm going to do is I'm going to layer over the top of my models. So let's take a look at 2/5. I'm going to layer over the top of my 5ths, 8ths. Beautiful. So it was once 5ths. When I layer 8ths on top of it, now I have 40ths. I'll do the same thing with my 8ths. I'm going to layer over 5ths. What was once 8ths is now 40ths. So my new denominator for my fractions are going to have the denominator of 40. And now what was once 2/5 is actually 2, 4, 6, 8, 10, 12, 14, 16 40ths. 3/8 has now become 3, 6, 9, 12, 15 40ths. When I add, I'm just going to add across my numerators to find the total, which is 31 40ths. That's one way that you can rename and get equivalent fractions, by drawing a picture. Now, if drawing a model ain't your thing and you can do this numerically in your head, let's take a look at what this would look like. All right, so some parents, this might sound familiar to you because these are some terminologies that we learned as kids. So we're going to find the least common multiple to come up with a common denominator. So I'll take my 5ths and my 8ths. I'm going to list out or just think about the multiples of each of those numbers. So we got 5, 10, 15, 20, 25, 30, 35, 40. Sorry, I ran out of room. Or we got our 8ths. We have 8, 24, 32, 40. Right, parents? So this looks familiar to us, right? So 40 is the least common multiple of 5 and 8. So 40 is now what my new denominator is going to be. So when I rewrite them, I'm going to rewrite them with my new common denominator. My least common multiple is 40. So now we're going to use our knowledge of basic multiplication facts. which was a skill that was taught in the 3rd grade. So parents, if your student is struggling with doing this next step, it's because they are going to have to practice their math facts at home, okay? So let me think. I went from fifths to 40ths. So I know in my head that 5 times 8 is 40. So whatever I do to my denominator, I must do to my numerator as well. So if 5 times 8 is 40, 2 times 8 is 16. And I'll do the same thing with 3/8, right? So let's switch my color marker to blue. There we go. I went from eighths to 40ths. So in my head, I'm thinking 8 times 5 is 40. So 3 times 5 is 15. There I have my equivalent fractions for 2/5 and for 3/8. When I add to get the sum or the total, voila. Okay, so I just taught you 2 different strategies that I taught your students as well, to rename, to make like units, and then to add fractions as well. Let's try another example because practice makes permanent. Now we're going to take some time to subtract fractions, but using the exact same steps. So we'll take a look at 5/6 minus 3/4. So this time, instead of talking you through every step, I'm just going to solve so you guys can watch and listen and follow along. So I can either draw a picture, I can draw 5/6 and 3/4 and layer them over the top of each other, or I can do it numerically. Now clearly I'm very proficient in this, so I can do it really quickly numerically. Like I know in my head already that the least common multiple of 4 and 6 is 12. But for students who cannot do that as quickly as I can, they can list the multiples of 4 and 6 to find the least common multiple. So we'll do 6, 12, 18, 24, and that list goes on and on. Then we'll do 4, 8, 12, 16, and so on. You'll notice if you continue these lists, though, we're going to have more common multiples. But in this case, we want to find the least common multiple. Alrighty, 12 is our least common multiple, okay? The least common multiple now becomes our common denominator. So I'm going to ask myself, okay, Mrs. Bowers, I got from 6 to 12 by partitioning into halves. So 6 times 2 is 12. What is 5 times 2? 10. Now, we went from fourths to 12s. 4 times 3 is 12, so 3 times 3 is 9. Now, this is just plain old normal 4th grade subtraction of fractions. 10/12 minus 9/12 is 1/12. Okay? So let's debrief. Let's kind of think about the work that we just did together, right? So first we made like units, and we do this when we can draw a picture, or we can find the least common multiple when you list the multiples of the denominators. All right, now I'm going to quickly jump ahead to something a little bit more challenging. This is what I taught your students today. So we're going to apply these same skills of renaming fractions to make equivalent fractions and then adding or subtracting. Today I taught them how to do this work but with mixed numbers instead. So let's take a look at an example that we did today in class. 2 3/4 plus 8 7/8. Okay, first thing I ask my students is, are these denominators the same? And they all go, no, it's not. But then I ask them, but are they related units? And they'll all say, yes, because 8 is a multiple of 4, or 4 is a factor of 8. So again, we can use that process of listing out the multiples of 4 and of 8 to find the least common multiple, which in this case is 8, which is great for us because this fraction here is already in eighths. So I'll just need to rename my 2/4. So let me just erase this really quick. All right, let's rename my fourths as eighths. So I'm going to write it vertically. So I'm going to ask myself, how many eighths are equivalent to 3/4. So I'll do this work. Well, 4 times 2 is 8. So what is 3 times 2? And that is 6. So here's my equivalent fraction to 3/4. Alrighty, so now here's the part where I might lose some people. So try to stay with me here, okay? So there's 2 ways that you can add mixed numbers. I taught your students 2 different strategies today. One is to think of it as a number bond or like unit form. So we can add our whole numbers first, right? This is kind of like the easier way to do it, I'd say. So we'll add the whole numbers first. So 2 plus 8 is 10. And then we'll add the fractions next. So we'll think 6/8 plus 7/8 is 15/8. And for right now, I'm going to have them leave this improper fraction as an answer. That's okay with me. I know some parents have asked if I want them to start simplifying fractions or renaming improper fractions as mixed numbers. I'm not going to push them to do that quite yet because I want them to have this foundational understanding first, okay? So I know that 15/8 is an improper fraction, but for now, we're just going to keep it like that. That's okay with me for now, okay? Now, a more challenging way to think of this, and I think that this approach or this strategy really pushes students to really think outside the box here. So it's kind of like a more challenging way to think about this, but I feel like a lot of my students are ready for this kind of thinking work. So kind of watch what I'm going to do here. So we already named 3/4 as an equivalent fraction of 6/8, right? So this time when I add, I'm actually going to try to make life a little bit easier for me by taking my 8 7/8 and turning it into a nice even whole number with no fractions. So today I asked my students to look at 7/8. And I asked them how many more eighths are needed to make a whole number. So a lot of kids would say, oh, you need 1 more eighth to make 1 whole, right? So what I'm going to do here is I'm going to make my life a little easier, and I'm going to make my 8 7/8 a nice, even whole number. But by doing so, I need to do some kind of borrowing from my other addend. An addend is just a fancy schmancy way of saying a number we're adding, okay? So I need 1 more eighth to give to 7/8 to make this 8 7/8 a whole number up to 9, right? So if I take 1/8 out of my 6/8 to give to my 7/8, what I'm left with here is 2 5/8, right? Would you agree that 2 5/8 plus 1/8 is 2 6/8? Right, okay. So now I can just do some really quick adding here. I'm just going to add my whole numbers, which is 2 plus 9. 2 plus 9 is 11. And I was left with 5/8. So I'm going to add my 5/8 to 11. And there's my final answer. Okay? So this is kind of just like a recap of the work that we did this week with math. I hope that you find this video helpful, and I am going to try to do better in the future with posting some more recent videos. A lot of my old videos, they still are applicable for sure because I'm still teaching the same topics and using the